Hello everyone, welcome to Duodecimal Division. My name is Eric Larson. In this video, I'm just going to go over all this numeral stuff one more time. I'm starting to get some feedback from people now, and one of the first comments that they make, or one like sort of against or being critical or skeptical, which is great. I'm glad. I want people to be skeptical, to really test this out and say, does this make sense? Is this logical? How can this be? The idea that the numerals are based on this series of circles, a geometric pattern. So I've already explained this series of circles and those lines and everything. What I'm going to do now is just go through, because the comment is, well, you've made it up, and anybody can take all those numerals, all the numbers that we know, the numerals, and place them on this series of circles in any old order. And the fact that I've done it in a certain way just is using my imagination. It's very easy. It would be very easy to mix them up. And so what I'm saying doesn't really make any sense, or it's not such a strong argument that they all fit so precisely within the circles and how the circles line up with the grid. So what I'm going to do in this video is just go over very quickly. I'm going to draw the circle, and you're going to see it kind of isolated and the numeral sitting in it, and then I'm going to just put all the lines, the values of the lines above. So here we are with the numeral. I'm going to go from 2 to 11. I'm going to skip one, or I'll do it at the end maybe. So this is what I mean right here. Okay, so again, all the numerals are being drawn on this. You can look on my other videos where I give the coordinates of everything. All I want to do is to show all the versions. Like there's the numeral 2 in the square root radius 2 circle. So we have the value of 2 right there. We have the value of the square root of 2 from the center to the edge. That's the radius of the circle. And then 2 root 2 is that length of line right there. So that's it. There's all the 2's in there. And so I guess my challenge is take that symbol and fit it into another circle, any circle that you want that's not like that, and get the same value of that number in that configuration. So you'll notice that every numeral contains the value of the number that it represents. That's the key kind of ingredient, and it's very important to realize that. Like that's quite, as you see, each one. And so now I'm going to go through them all, and you're going to show you what I mean. Okay, so here we have the numeral 3. We got the center point. You can see that it's 3 units tall. That length there is the length of 3. So the distance from here to here is the square root of 3. And the distance from that little point there to that line is 0.3. So there's 3 aspects of 3 that are incorporated in the numeral that represents the number 3. All right, here's the numeral that represents the number 4 inside the square root radius 4 circle. So the length of that middle line there is 4. The length of the line from this cross here up is 3. This length of that line is 2. The length of that line is 1. That's why the number 4 looks the way it does and how it fits into that circle. Again, see if you can fit it into another circle where you have that same, where everything lines up the same way. That's the numeral that represents the number 4. Okay, here's the numeral that represents the number 5. And incorporated inside that symbol is the length of 5, where you add 3 plus 2. So basically it's 2, 3. The length between there is 4. 3 and 2 is 5. And then the square root of 5 is also, between here and there and there. And then from there to there also is the length of the square root of 5. So all those are symbols, all those lengths are incorporated in that particular symbol, the numeral that represents the number 5. All right, here's the numeral that represents the number 6. Has the circle is the square root of 6 radius. So the height, here's the coordinates of 2.6 and 6. That's the coordinates of that point right there. So that gives us, we have the 6 is the height from this point here to that point there, just like the 3. Square root of 6 obviously is the radius. 0.6 is each of these, we're going up at a 45-degree angle. So each of those points here is exactly in the middle of each of those sections of 1. And half of 1 is 0.6 in duodecimal. So we have 0.6 going all through there. So this point here is just outside of the square root radius 6 circle because it doesn't actually intersect any points, similar to the square root 3. So this line here going to that point there, the coordinates of that point point are minus 1.9 for the x-axis and 1.9 for the y. So that's a 45 degree line. 1.2 or 1.9 root 2 is the length of that line, which works out to the square root of 6.16. And then this line here itself, also on a 45 degree line, is a 4.3 over 4.3 up. So 4.3 root 2 equals 30.16. Okay, so that's the numeral that represents the number 6. All right, so here's the numeral that represents the number 7. We have the height of the numeral is 7. The length of that line there is half of 7, 3.6. The distance of this line, or the length of that line, is 2 times 0.7, so half of that length, or the distance from that line to there, is 0.7. And the slope of this line is down 1 over 0.7, down 1 over 0.7. The distance from the center of the circle to either one of these points here is the square root of 7.09. So that's the closest I could find in here of the actual square root of 7 length. So the coordinate points of that is x is 1.9 and the y is 2. Okay, so that's why the numeral 7 looks the way that it does. Okay, so here we have the numeral that represents the number 8 and the square root 8 radius circle underneath in red. So in this symbol we have the height of 8, and that symbol is touching all 4 points where that square root of 8 radius circle is touching the grid on lattice points. So it's only the numeral 2 and the numeral 8 that actually touch all the points where that circle is hitting the grid. Yeah, the height of 8. We have the length of 4 incorporated in there. That's the radius, or the diameter of those 2 circles. And then, the distance from the center here to that point is, exactly square root of 8. The whole diameter of the circle then is 2 root 8. And I just did a calculation that the 2 root 8 in duodecimal is the square root of 28. So there you go. Lots of interesting things keep showing up when you do it in duodecimal. That's why the numeral 8 looks the way that it does. And again, good luck fitting that symbol into any other circle grid combination where you yield that same result with the height being the number 8 and all that kind of stuff. All right, there you go, the numeral 8. All right, so here we have the numeral that represents the number 9 and the numbers that are encoded in. Actually, I just realized I made a mistake. In the last section, I said, the 2 and the 8 are the only symbols that are touching all the coordinate points of the circle. And here is the number 9, or the numeral 9, and it does exactly that also. So let's add the numeral 9 to that list. Here's the 4 points where that circle touches the grid, and of course the symbol is touching all those points also. And actually, really, the square root 6 radius circle, that whole circle is a square root of 6, so it's actually touching, although there aren't any points, it's still touching the whole grid because the whole circle is there. All right, anyway, a length of 9, that line is 9, or if you use this version, I sort of incorporated 2 versions in one here. If you use the version we got this curve, the distance from there to the top of the symbol is 9, just like the 8 and the 7 and the 6 are all incorporate, and the 3. Well, the 3 and the 6 is like from the midpoint to the top. This is the whole symbol. Length of 9, square root of 9 is 3. So the radius of that circle is 3. The diameter is 6. The overall height is 9, or the length of that line is 9, 3, 6, 9. That's why the numeral 9 looks the way it does. The numeral 9. All right, so here we have the numeral that represents the number dec when you're counting in duodecimal, which is the number after 9, 7, 8, 9, dec, L, then do apparently is the name of 10 in duodecimal. Either way, there's the 10th circle in the series if you're back in good old decimal. Anyway, that's how that symbol fits on that square root of dec radius circle. And the distance from there to there is 5, so 5 and 5 is dec. So you have the length of 5 incorporated in the symbol and the length of dec in the height there between. That's why you have these little kind of wings going out. And then this line is the same as that same line as the one for the 3 and the 7 and this one here. This one is a little bit over, just compensating. It's connecting those 2 points right there. The only question I really have is whether this line goes over and is intersecting an actual XY coordinate plane lattice point, or whether it's stopping on the circle. If it stops on the circle, then this length here is exactly square root of deck, and that whole line is the 2 root deck. So there you go. That's why the numeral deck looks the way it does. And again, you know, try and fit that symbol on another circle size and still have the numeral or the value of that numeral represented in the symbol. All right, the numeral deck. All right, so here we are with the last symbol, the last numeral, the numeral called L, and it is 11 units tall, or the L units tall. So here we have, you know, from there you go 1, 2, 3, 4, 5.5. So 5.5 and 5.5 is 11. And you can see I've also made the marks on that circle, the square root of 11 or L radius circle, that's the red one. I've marked off those same degree lines that we've been looking at the whole time. Okay. And you can sort of see where they're going with that. They being the people that designed this, that this symbol kind of breaks up the circle into 3 equal units somehow. So I've got a marker here just to sort of show you. This is still rough, but there's that length there is the same as this one here, obviously. But this also lines up really close to that also. So that's why I'm in the process of just confirming, really narrowing that down and getting it precise. But basically that's not what this video is about. It's about just showing how well these symbols, one, each incorporates the value of the number that it's representing, and 2, how difficult it would be to mix them all up and have this symbol somehow interacting with the square root of 7 or 5 or 2 or any other circle, basically. And that's kind of my challenge in a way, is to just ask anyone, because this is really the evidence. This is the proof, is simply how they do fit so perfectly when you really line them up and look at them a certain way. So yes, you have to kind of tweak the numerals, but these are like the bones again of the actual symbols, and all the different designs that we see in the world, the different versions or fonts of the numerals come from these basic shapes right here. That's my argument or my hypothesis, and I just want to share that with you. So I hope you enjoyed this little video. There's more to come, especially with this one. This is the one I'm working on right now. I really want to get it perfect. Okay, so that's my project for the rest of the day. Hopefully I can make another video at the end telling you what I figured out. Thanks for watching. Bye for now.